Exam 3 is gonna be on November 18th, which is a Tuesday in class. It covers modules 5 and 6. All group works, quizzes, all are posted. Lecture notes, solutions are all available. So make sure you practice that. But this is gonna be the actual study guide. Practice version A, practice version B, and you know where to find these, right? And I'm going to solve the free response for both versions in today's review, because the fill in the blanks and the multiple choice, if you send me a few questions you want me to solve from the fill in the blanks, send me emails until Friday midnight. Okay? On questions, which question is this? Question number 1 to 9. On whatever questions you want me to solve, and I'm gonna have a Zoom meeting for multiple choice and true false only. Okay. Today I want to focus on more of the algebraic stuff. Free response. Okay. As everybody knows, we are in the world of integration now, anti-derivatives as we call it, right? This is a practice exam. Of course, it's going to be a little bit more lengthier, more difficult, more questions. Actual exam is going to be similar type of questions, less number of those, less difficult. Okay. So before I move on, let me remind you, and you want to take a sticky note. Do you guys have a sticky notes? Well, you should get those. Okay. No, there is not much formulas to remember for this exam. I'm looking if I have I don't. So bring those, okay? And these are you cannot use them on the exam, but there are only 3 formulas that we really need to remember. Formula 1, because I'm not going to talk about derivatives. You guys are champions in derivatives. You have done a lot of difficult things in life. You know how to handle derivatives. I'm going to only talk about anti-derivatives. This SUC, as some of you like to call it, is the symbol for anti-differentiation. Okay, just like the prime was the symbol for derivative, this is the symbol for anti-differentiation. Okay, if I see x to the power n dx, this is just a refresher of the rules. These are crucial, extremely important to do well in all of the questions that I'm going to be solving with you. So make sure you memorize them. Question. Okay, yeah, answer is because it's anti-differentiation, you plus 1 to the power divide by it, right? It's kind of the opposite of what we used to do in the derivatives, where you bring the power to the front and subtract 1, right? Is the opposite. In every derivative, you have a plus C going on. Similarly, the other very important rule that you must remember is the constant rule. If I have a constant k is a number, okay? K could be any number. If I have a constant inside the integration sign, just focus on the constant. The integration sign, the little s here, and the dx is part of the question. We only focus on the number inside. If it's a constant, if it was a derivative, you would make it 0, right? But because it's the opposite of that, you will multiply it by the variable or x. In this case, it's x. Sometimes it's t, sometimes it's some other variable. In this case, this is s. Okay, x. The most important rule, if you have 1 over x dx, okay, 1 over x dx will be ln x, right? Go the opposite. The derivative of ln x is 1 over x. So this is a special rule. Okay, remember this. Okay, next. What do you think will happen with e to the power x? Is just e to the power x. No extra math required there. It stays the same. But if I had e to the power something multiple x, some number there, okay, then you know what you used to do in differentiation? You used to multiply by it, but here you divide by it. And nobody will ask me, well, how am I supposed to know if I'm supposed to differentiate or anti-differentiate? You see this big symbol here? This is your hint. This is telling you right now to anti-differentiate, okay? You're supposed to use these rules if you see this symbol. And I'll give you more hints as we go along the paper. Questions will be very similarly phrased in exam. So if I'm using anti-differentiation rules here, that's what you're supposed to do in exam, okay? Now, all the rules, this is it. This is nothing new. You already have memorized these rules many times. You've been using these rules. So this is all we need to memorize for the coming up questions. Now, moving on. With this example right here, I have two brackets, right? Everybody can see the question, right? Everybody have access to the practice exams. It's on website. The first thing you want to do is do not look at the solution. Solve it yourself first, okay? Simplify. I'm gonna foil it. Foil, fold, whatever you call it these days. So the symbol remains because I'm not applying any of the rules on this side here. I am just foiling it. So 3x squared times 2x is 3x squared plus 1 is, times plus 1. You know how to do this. 8x squared negative 4x, right? I did not apply any rules. I am just multiplying the brackets. Everybody can do this, right? Can you combine the like terms? This one looks the same. So what do you get? 6x cubed minus 5x squared minus, solve it with me, okay? Try to solve it with me. And now, question. I cannot simplify it any further, right? So now I apply the rules. You know the rule, if I have an x to the power n, I add 1, I divide by it, right? The 6, which is a multiple of x, is just like derivatives. It stays there. Nobody touches the 6, okay? So this will be 6x, 3 plus 1 is, there you go. Same thing with the next one. 2 plus 1 is 3, right? And this is power 1, so 1 plus 1 is, am I done? Plus c. Simplification, optional, you can leave it here. If you leave it here, I'll be very happy. Full credit. If you want to simplify, be my guest, okay? That is also full credit. If you want to do 3 over 2, x to the power 4, minus 5 over 3, x to the power cube, minus 2x squared, plus c. This is also good. Okay? Make sense? Everybody can do this question. You will see a question like this. Alrighty, moving on. Now I have this, I have a thing in the denominator, right? What's the first thing I do? I simplify. Simplify this. Move the x cube with each and every term. I'm gonna write a little small, so those who are at the back can sit in the front. There's a lot of space here, okay? Because I have to fit my solutions here. 7 root x. So the x cube goes with everybody. Everybody gets the x cube. Good. And copy the dx as it is, because the integral symbol and dx are part of the question, okay? You only are focused on what's in the middle. Now simplify this. Now, you know what's the best way to simplify a power of x on the top, power of x in the bottom? You subtract it. Subtract the bottom from the top. Remember this, okay? Everybody should have their calculators out. If I see a phone in your hand, I'll be mad. Calculators in your hand is the tool I want. Nothing else. Okay, now, this is what I want you to do. I want you to take the power on the top, subtract the power on the bottom. If you see a square root, you know what's going to happen. It becomes x to the power 1/2. Good job. So simplify it one more time. The 2 remains. The power will be top minus bottom. Same thing. The 7 remains. Power will be, well, the top power is 1/2. So it will be 1/2 minus the bottom power, which is 3. Make sense? The last term, there is no x in the top, but I can move the bottom one by making it negative, right? That's a very common rule. We have done this in differentiation. If there is something in the denominator, you can move it up by making the power negative, right? It's basically 0 minus 3. So negative 3. Okay, now do this in your calculator. What is, simplify a little bit. See what you get. So this will be, oh, this is power 1, right? Power 1 will be 2 over x. That's a special case. If you have x to the power negative 1, just remember that's 2 over x, okay? Half, yes. Exactly. Because that's a special case. You cannot do power rule there. Even if you try to, it will not work, okay? You will know that you have made a mistake. What about 1/2 minus 3? 5 over 2. And this is just 5x to the power negative 3, right? See, so far, I am not applying any rules on the highlighted side of the notes, right? Because I'm not applying any rules, the antiderivative symbol stays there. As soon as you apply the power rule, the symbol will go away. You will add plus c, okay? When you apply the rule, you apply the rule on each and every term. You don't do it step by step. You cannot say, oh, 2 over x is 2 ln x and leave everything as it is. Follow the procedure, okay? Make everything as a power first, then apply the rule on each and every term. By rule, I mean formulas on the side. On each and every term together at the same time and remove the symbol. So now I'm applying the rule in this step right now. 2 over x becomes 2 ln x. And what is negative 5 over 2 plus 1? Come on, somebody. And divide by it, right? What is negative 3 plus 1? Negative 2. Am I done? Plus c. If you miss a plus c, you know what's going to happen? It's wrong. I'm going to take points off, okay? This is the answer. You can leave it here. I'll be very happy. Yes. If you were to simplify, yes, then you would do 7 times 2 over 3 and negative. Yes. If you want to do that, I have simplified solutions on the solutions. When I was making solutions for this, I wrote the simplified answers, okay? So you can refer to that if you want to simplify further. Now let's go to the last. Oh, it's not the last one. Oh my God. Okay. What's going to happen here? Well, this is already simplified, right? I just apply the rule on each and every term, apply the power rule. So you would get negative 5 over 2 plus 1. Use your calculator. It will be. And what happens to e to the power something? It remains e to the power something and divided by the exponent, right? Quite the opposite of what we used to do in differentiation. We used to multiply, but here we divide. Okay, we are using this formula right here. This formula. Good. That's it. This was a one-step problem. Well, use this formula. If you have e to the power a times x, it remains e to the power ax divided by a. So a here is -3, divide by. Add 1. Right? You're applying formulas, right? Okay. Here, same thing. I think you're getting the drill of it. How do I simplify this power? Actually, you know what? You can ignore this term. It's just too complicated. Okay, now simplify these powers. Is just x to the power 1/2 plus now this is straightforward. What is half plus 1? Divide by it. The -3 remains. Don't forget the -3. Plus, what is 3 plus 1? Now, if you feel like you have enough time on hand and you've double checked all your answers, you want to simplify it, then in the denominator, if you have a fraction, you multiply by its reciprocal. So this will be question.
That first term that you scribbled out, is that going to be on the exam, or is that too hard to do?
Too hard. Ignore it. Okay? I mean, it's good for practice. You should know this. But I don't want to waste time. I have too much questions to solve. Okay? All right. What about here? See, I have an x in the denominator. I have a 5/9. The numbers stay as it is. Numbers don't change. This becomes 5/9 ln x. Okay? And the e to the power -2x remains e to the power -2x, but you divide by plus c. That's it. Let's do a few more questions here. I'm just going to write it here. If I gave you 7/3x plus e to the power 11x plus 5 dx, what would you do? It's a test for you. Can you solve this? Who's going to answer? Lee, what's the first term? What's the first answer? Seven over 3 ln x. Right? Okay. Who's gonna answer? Not you. Come on, somebody. Okay. Dean. Good job. Come on, who's gonna answer? Don't answer. Just raise your hand. Okay, Nicole. 5x. Right? Constant becomes 5x. We're not dividing it, right? Constant just gets multiplied. That's the rule. If you see a constant in the question, multiply by x. Make sense? Can everybody do this question? Okay, you're ready then. Next one. So you will get questions like this. This is 6.2. Initial value problems. It goes in 2 parts, okay? Step 1. This is what you're supposed to do if you see a question like this in exam, which you will, okay? Now, f prime x is given to you. To find f of x, this is what you're going to do. You're going to find f of x by anti-differentiating. Copy the derivative, which is given to you in the question, plus 6. Put it in a bracket, dx. Is this clear? If I, yeah, that's the notation. This is the notation, okay? You can do capital F. No, just use small f, because we are already using the prime here, right? But that I wouldn't be worried too much about, okay? Now, can we integrate this one? You are champions of finding the formulas for this. Let's do it on this side. So what is f of x? Add 1 to the power, divide by it. Add 1 to the power, divide by it. If you see a constant, multiply by x plus c. Good? Everybody should be able to do at least until here. Okay, but now these questions are slightly longer because you're given the initial condition. Now this is where I saw in the quiz, a lot of you were using shortcuts and getting the wrong answer. Now take out your calculators. I want you to get the correct answer. This is how you set up the equation in exam. If you have f0 equals 4, you know what it means. Use this f0 equals 4 means when x is 0, function becomes 4. It's not c, it's the value of the function. You have to find c. So function becomes 4 equals, plug in 0 for x. So 0 cube over 3, 0 square over 2, 6 times 0 plus c. Okay? Now what is this? 2 times 0 is just going to be 0. So I've got 4 equals c. Well, this was easy to find, right? Everything else was 0. As soon as you get c equals 4, you know what you're supposed to do? Plug it back into the equation. Somebody has been practicing. Good job. Okay. I want all of you to be very eager answering like this, okay? You see what I did? I replaced the c with what we found. That's it. This is done. The final answer is done here. This is the correct answer. Let's do one more. I have plenty of examples for you. We'll do the same thing. We'll find f of x. F of x, it's a procedural question, okay? You're adults, you can remember 2 steps of a question, okay? F of x, what do? I copy the integral symbol, copy the question, 2e to the power negative x dx, and integrate it. What do I get? 5e3x, right? Over 3, good job. What about this guy? -1, right? Because the coefficient is, do not forget the -1, and no, you don't add a power to e. E has a special rule, just like e had a special rule when we were doing derivatives. Okay, now this is done. This is the function, but I still have a c here which I need to solve for. So I use the extra condition. f0 equals 1 tells me that 1 equals when I place 0 in place of x. So it will be e to the power 3 times 0 over 3. Now take out your calculators and solve for this. Well, -0 is just 0. And you know, e to the power 0 does not become 0. Do not use shortcuts. E to the power 0 is 1. You will get the answer wrong in the exam. So when you solve for this, this will be 1 equals, plug this in your calculator, see what you get. -1/3 for what? You have to solve for c. So what is c? How many are getting 4 over 3? Okay, something is off then. Let's solve it here. So 1 equals, this is -1 over 3 plus c, right? But I have to solve for c, so I have to add it to the other side. I should get 4 over 3. So c is 4 over 3. Nicole, check your math. double check everything. Then I'm not done here. I have to rewrite the function. Yes. Okay, then we did something wrong. So double check the work at home, okay? Plus 4/3. But do you understand the process? That we are solving for C. C does not equal 1. Do not do this in the exam. Make sure you practice enough, okay? Yes. Leave it as fraction or keep it decimal. I don't care. I would like fractions more actually. Okay. Let's do one more. Yeah. F prime is 4/x. F of x will be, integrate that guy. 4/x is 4 ln x plus c. This thing is just telling you that x cannot be negative because log of negative values is not defined. Okay, I'm not done here because I have to still solve for c. So I'm given f1 equals 2. So this tells me, this is exactly how you write. 2 equals 4 ln 1 plus c. Now what is ln 1? So 2 equals c. This was okay. So the final answer is 4 ln x plus 2. It's a two-step question, yes.
Number in the denominator for the original equation, like
5x.
something.
Then you do this. If you have 4/5x, it becomes 4/5 ln x. Okay, good question. That's why I did this example. All possible types of questions that you will see on the exam are on here. If you solve this and the other version at least 2-3 times, nothing will surprise you on the paper. Okay. Alrighty. Last one. What is the integral? I'm just gonna write root x as power because why not? Right? Apply the rules. Is half plus 1 is what? And 3 plus 1. Right? Then I solve for it. F1 equals 0, which tells me 0 equals when I put 1 in the equation. Okay, you need your calculators for this. 1 raised to anything is just 1. So what is C here? Come on, somebody solve this. What do you get? Which side did you get that? Anybody else getting -5/4? C equals 1/4 minus 2/3, right? You can use your calculators. Don't mind me. I'm just solving it. -5/12, right? Okay, there you go. There you go. So C is -5/12. I'm not using a calculator, but with a calculator, it should be very simple. So the function, then you make sure you box your final answer so I don't have to look through your work. x3/2 over 3/2 minus x4/4 minus 5/12. And put a box around your final answer. Okay? So if you get questions like this, you know the drill. They are long processes, but they're using the same formulas that we wrote on the previous paper. Good. They're not easy. And you are very likely to make mistakes if you don't practice. 3 minus 8. Simplify this. What is 1/3/2 minus 1/4? In your calculator, do this. In your calculator, plug this in. You will see that this is 0 equals 5/12 plus C. It is not, but It's C plus 5 over 12 equals 0. So what is C? Okay, you practice, okay? These things can throw you off in exam and get the wrong answers. So practice, okay? Alrighty. Next, we go back to the good old derivatives. Okay, this is like a joke of a question for you guys. You have done so many difficult things in life. What is f prime? Now we cannot forget the derivative rules, okay? You are champions in derivative rules. I will not waste any time explaining this, okay? What is f double prime? Okay. How do I find critical points? Now, when I make f prime equals 0, I have to use quadratic formula to solve for it. Or I can factor it, or maybe I can divide by 3. Let's see what you get. Negative 3x squared plus 10x minus 3 equals 0. Can you factor it? No, you can't. Oh, you need 9, right? So 9x plus 1x. Who said you can't factor it? You can use quadratic formula all you want. I'm gonna factor it. Okay, I like factoring. Okay, so what I got x minus 3 equals 0. And I've got negative 3x plus 1 equals 0. Now, of course, the critical points will be nice integers, okay? Won't be fractions like this. But I've got 2 critical points. So I've got 3 and 1 over 3 are 2 critical points. Everybody, you have found critical points so many times in the past. This should be, you can do this in your sleep. But how do I classify critical points as relative, maxima, or minima? Now you must be thinking, oh, I have to draw the number line, do all that stuff, right? You're not supposed to do that. Hint, use the second derivative test. It's way easier than that. How do I do the second derivative test? You know what you're supposed to do? Plug your critical points in the second derivative, see what you get. I'm going to delete all this work. I have faith in you. You can find this or you can solve this on your own. I'm just gonna, oh God, I'm just gonna tell you because I need to write more stuff here. I'm just gonna write this because you can use quadratic formula or whatever, just whatever math method you use, make sure you get the same answers as this. Now, because they want me to use the second derivative test, that's your hint. It will be given to you in the exam. Use second derivative test. Do not draw number lines. I don't want happy, sad faces on the paper. Okay? That's what we did when we did not know any better. F double prime of 3. What do you get? Plug it in the second derivative. Is it negative or positive? F double prime of 1 over 3. Come on, somebody. It's negative? Anybody else getting negative? It should be negative. What about this one? It should be positive. What happens when second derivative is positive? It's concave up, right? It's a relative minimum. Good job. So second derivative of test tells me that x equals 1 over 3 is relative minimum. And what about this? X equals 3 is relative maxima. You see how easy it is? With the second derivative, you already found the second derivative. All you have to do is plug it in. If it's less than 0, it's max. If it's more than 0, it's min. Okay? Find the intervals of concavity. To find this is the trick. To find the intervals of concavity, I'm first going to find the inflection points. How do I find inflection points? The second derivative becomes 0. Remember this, okay? Second derivative was negative 18x plus 30. Make it 0. You get x equals negative 30 over negative 18. 10 over 6 is 5 over 3. I have got one inflection point, which is very likely because you only have a degree 1. Now that you have the inflection point, plot it. Here you need to do the plotting, okay? Because you need the intervals of concavity. The drill is the same. You're checking for signs of the function. Pick a test point here. F double 0, F double prime of pick a number 0. It's if I put 0 here, I get positive, right? If I put a number, say 10 here, I get negative. Negative means concave, down. Positive means concave up means F double prime is greater than 0. This means F double prime is less than 0. On the test point, you have to find the inflection points first, okay? Making F double prime equals 0. It will be very straightforward question. What does the concavity reveals about the graph? Write one sentence that function is, just say that F double prime is greater than 0 on negative infinity to 5 over 3. F double prime is less than 0 on 5 over 3 to infinity. Okay? That's what it tells me. Good? This is derivatives. There is no integration going on. Watch this video again and it will make sense to you. This is something similar. You have done this in the past. Now, moving on. A tank initially contains, every time they use the word initial, that's your hint. If I say initial, this is a question of antiderivative, okay? And I've also given you a condition here, V0 equals 1200. That's the initial condition. Water drains from the tank, okay, blah, blah question. Now I've given this. Volume derivative, it's not V, it's V prime. How do I find V? Integral. That's your hint. Copy the function. I think we have solved enough problems of this type. Instead of dx, this is dt. Okay. So what do you get here? It remains as it is, but divide by, that's the formula, plus c. Simplify this, what do you get? The negative negative will cancel. Is it just 1000? For the application part, it's useful to simplify them because they get easier. Now, because I have to find C, which is given to you in the question. V0 equals 1200 means 1200 equals, when time is 0, 1000 e to the power negative 0.03 times 0 plus C. So what is C? E to the power 0 becomes 1. So C is 200. Right? Something that we were doing already in the question number 10, but now it's just an application part. So what is a volume function? When I replace it by C, 1000 e to the power negative 0.03 t plus 200. The formulas are there. Same formulas we are using. It's just you have to remember what to do in a question like this. That's the most difficult part, trying to memorize the steps. What step to do? Okay, how much water in the tank after 5 hours? Well, plug in 5 times 5 plus 200. Plug this in your calculator. That's how many? 5,000? 1,000. Anybody else getting the same answer? Okay, you plug it in. Okay, see what answer you get. Determine whether the volume function is concave up or down over time. The volume function has e to the power negative. It's always positive, right? Exponential function is always positive. So the function is concave up. There you go. So the water is draining faster. But this is in my solutions, you can see that. Estimate the time. Okay, ignore this part also. Alrighty. Whatever I've ignored, you're gonna ignore, okay? Alrighty. Moving on, number 14. Now, do I use any integral initial value or anything here in this question? No, right? So this is a question of good old derivatives. If I give you the position function, you know that the velocity is the derivative of position. Acceleration is the double derivative of position, okay? This is something we talked about it in my lecture notes in 5.3. Velocity is the derivative of that. Acceleration is the double derivative. So what is velocity? Find S prime. What do you get? 60 square minus 24t plus 18. What will be the acceleration? There you go. Good job. And this is what we are using. Now, well, this was very straightforward. Find acceleration at 2 seconds. So 12 times 2 is coming out to be 0. Units, look at the solutions. Make sure you have the correct units, okay, when you solve this again. Find the acceleration at the time, at the instant when velocity is 0. Now, velocity is 0 when? Bless you. So, velocity is 0 means you have to solve for the quadratic. So, 6t square minus 24t plus 18 equals 0. Now, factor this. What do you get? Factor this, you get t square. I'm going to divide by 6 first. So t square minus 3t minus t plus 3. I am splitting the middle term. I have a video on this already from exam 1. So watch my video if you want to do this. I've got t minus 1, t minus 3, right? The velocity is 0 at time equals 1 and time equals 3. So find the acceleration when time is 1. Find the acceleration when time is. That's it. This is all it's asking you to do. Good? Good, everyone? Okay. A YouTuber, now it's again, they're telling you find the first and second derivative. So first derivative is, okay, this is a joke of a question. Everybody can differentiate this. What is the second derivative? Right? Now they're asking us to find inflection points. First, find inflection points. Inflection points are found by making double derivative equals 0. So you get So T is 2. Now, once you have your inflection point, go back to the intervals. This is whatever I'm writing on this paper is what you're going to write on your exam. Exactly this. You will follow the same process. This video will be posted. You watch it again and again. Okay. So what is the sign of the double derivative? Pick a point, say 0 here. Pick a point, test point here, say 4. S0 is negative, clearly, right? If I plug in 4 here, it's positive. So positive means concave up on 2 to infinity and concave down on. That's it. So what does it tell you about the subscriber rate of growth of time, blah, blah stuff? Write a sentence, okay? The rate of the subscriber is growing at a faster rate after 2 seconds or 2 years. Good. That sentence you can read through the solution. Okay. I think you can write one sentence. Now, these are the free response part. The only thing that these are differentiation. This is an integral function, but we solved similar questions before, right? I'm doing more. Wait, I'm not done here. The version B, the only questions that are different, okay, I'm only going to do the different ones. The different questions, these are the same, okay? Practice these. We did this already. Similar questions, they're just numbers are changed. You can ignore this part, or you can simplify it if you want, but for now we'll skip it. Let me see which questions are different. These are the same. This is the one that is different, right? In case you are stuck on this question, I'm solving it right now. Everything else, whatever I did in version A, follow the same rules. Only numbers are different, okay? Questions are the same. Lily? Oh, you're all dressed up. Oh, okay. Good job. Good luck. Alrighty. VT. Now, you know the why it's different. Okay, I'll see you Tuesday. Email me. See me office hours, okay? I have velocity given to me. I want to find is going the other way around. That's why it's different. Remember, velocity was the derivative. Acceleration was the double derivative. I'm going the other way around. I'm given the velocity now. I want to find the position function. Position will be integral of velocity. That's the only change in this question. Now we are all champions in, and this is another hint. If you're like, I don't know, I will not remember that velocity is a derivative. This is another hint. I am talking about initial condition, right? Every time I talk about initial condition, you know that you have to have a plus C somewhere. So that's the integration question. Okay, it cannot be more hints than this. Good. Watch the video again, okay, Marin? All right. Alrighty. So simplify this, what do you get? 2t cube over 3 minus 8t square over 2. Constant becomes, but there's a plus C, right? Good job. You're doing good job. Plus C, what do you get? How do I solve for it? It's right here, right? So I got 0 equals 2 times 2 cube divide by 3. Okay, somebody do this math. 2 square, 2 plus C. Now make sure you solve enough questions to know how to solve for plus C correctly. Okay, who's going to tell me what is this part, all of this? Some nice student who is ahead of me and not playing video games in the front row. Okay, come on, Evie. Nobody's on their calculator. Frida? Negative 2/3. On this side? Anybody else got negative 2/3? You know you have to do this in the exam. The faster you solve it, the faster we all go home. Okay, so if C plus negative 2, 3 is 0, then C equals 2/3, right? It's very subtle. If you don't practice this and get this part wrong in exam, I will know that you did not listen to me in the review. Okay, so what is the position vector? Is 2t cube over 3 minus 4t square plus 5t plus 2 over 3. And then it becomes the same thing. Find the position when time is 8. So plug in 8 again. I mean, you can do this. When is the particle at rest? It's asking you when the position is 0. The velocity is 0. This means velocity is 0. Solve for t. Solve for t. Yeah. Yeah, this is the whole function, right? You have to plug in 8 everywhere and solve it. Velocity equals 0. Velocity equals 0 gives me 2t square minus 8t plus 5 equals 0. Solve for it. Can you factor this? It's 10. 10, 8. Doesn't work. So use quadratic formula, okay? Now time cannot be negative. So if you get a negative time, you reject that answer. So there will only be one answer. Time equals 5 seconds or 5.3 seconds where the particle is at rest. Good. Now this is the same type of question that we have solved already. Let's just do this. Okay, this is a trick question. It's I gave you the same question in a group work, if you remember. What is the first derivative? Negative 0.2. What is the second derivative? Well, multiply this. What do you get? Then I have to multiply by negative 0.2 again. Right? I'm differentiating. Inflection point. There is no inflection point. Because don't waste any time in exam, okay? Because e to the power something is never 0. And this was a question in the group work and quiz, and most of you were present that day, so you will remember that, right? Because the second derivative, look at the second derivative. It's always going to be positive, right? It's never concave down. It's a trick question, but it's very simple. If you have solved it before, it should take you 2 minutes. Nobody should be wasting time on this. Okay? Any questions? Does it make sense to everyone? Frida, question? At the back? Claire? No questions? Okay. Vivan's friend at the back? Yeah, you're Vivan's friend, right? Never mind. Okay, you're not his friend. I thought you were friends with those two at the back. You are always sitting together. Yeah. Yeah, you're friends. Okay. Can you do this in exam? Alrighty. Okay, see, there is the hint right here. If I give you condition like this in the question, you know it's an anti-derivative, right? Because if I give you this condition right here, you know there will be a plus c. Height function will be integrate 8 over t. Last question that I want to go home too. So nobody will pack their bags. If I'm here, you're here. Dt. What is the integral? 8 ln t plus t square over 2 plus And you know there will be a plus C because you have to find it. So 0 equals 8L and 1 plus 1 over 2 plus C. So C is, see, if you don't give me an answer, we are stuck here. C is negative half. That's it. Then you have to find the height of the function at 4. So plug in 4 here, 8 ln 4 plus 4 square over 2 minus half. That's the height, right? This is the velocity. Velocity is at 2 means just plug it in the velocity function, right? And the units, you have to be careful. Units are all in my solutions that I've posted on the website, okay? But I just want to tell you, if you get a question like this with an initial condition, you know you're supposed to integrate with plus C. Question. Oh, the height function, I'm calling it, let's call it H, right? I called it S, but H makes more sense. Make sense? So these are the only variation. One of these questions will end up in one of the versions. So they're not as bad, but you have to memorize the process. You have to memorize the steps and the 4 formulas that we did. Not the 4 formulas, but where are the formulas? Here, right? These are the formulas. I'm gonna maybe hold a Zoom meeting on Sunday where I will go over the fill in the blanks, like these ones, okay? If I do one graph, the other graph will be very similar. And the MCQs, I'm gonna go over them briefly. This is just an integration question. But now that you know about the integration part, the MCQs are gonna be very straightforward, okay? Even if you just read through the MCQ solution, it will make sense. But I'll do record a video on Sunday, just for MCQs and graphs, okay? Okay, study everyone. Do not party too hard. I'll see you Tuesday with the exam.